Alright, in this video, I'm gonna try and trick you. I want you to look at these expressions where I'm checking for equality, right? I'm saying, hey, does true equal for 1? Does empty string equal 1? Do two arrays that are empty equal, well, each other? Now, pause the video here and try to guess what the outcomes of this are going to be. Ready? By the way, if you get 100% on this, well, good for you, because if this was my first time learning Python, I wouldn't get this. Let's go. True. Is that what you expected? True. Evaluated. So true equals 1 evaluated to true. An empty string equals to 1 evaluated to false. That makes sense because they definitely don't equal each other, right? An empty array doesn't equal to 1. And a 10 equals 10.0. And then both arrays that are empty equal to true. Now, the reason I'm showing you here is that the double equals checks for equality, or equality of value. That is, if, for example, the first one, true equals to 1, there's two different types. One's an integer, one's a boolean. It will convert them into the same type. In this case, this will be converted like this to a boolean value. And if you remember, 1 is truthy, so this will evaluate to true, which is why we get true. What about the other one? Well, an empty string is falsy, so it evaluates to false, and false doesn't equal true, right? Because we're checking for equality here. So one of these gets converted to the other's type. What about an empty array? Again, an empty array is actually falsy, so that's not going to equal 1. A 10 equals to a float of 10.0. That gets converted to an integer or a float, and they're going to equal each other, and that's an expected behavior. And then an empty array, well, equals an empty array. If I add in this array 1, 2, 3, 1, 2, 3, and I click run, I get an invalid syntax. Ooh, because I have this here. Let's run that again. I get true. That makes sense. Let's change this to 1 and see what happens. If I click run, right, still false. Now, this does get a little tricky, right? Like, should this have evaluated to true? But no, we get false, so this doesn't get converted in type versus what we had here. Now, don't get confused by this, because this would be bad code. If you're checking something like this, well, obviously you should be checking two of the same types together. Ideally, when you use comparison operators or logical operators like this, you're comparing two types, and you're not letting Python do this type conversion, and hopefully Python figures it out for us. But I hope the double equality makes sense, because there's another check that we can do, which is. And is, well, is a keyword in Python. What happens if we change all these equal signs to is? Do you think there would be a difference? Let's have a look. If I click run, I get false for everything. So what's the difference here? Equals checks for the equality in value, such as 1, 2, 3. Well, that has the same value as 1, 2, 3 in a list. Is actually checks if the location in memory where this value is stored is the same. Let's go through that. So true, is that 1? No, true is not 1. True is, well, only true, right? That will be true. What about string 1? Is that 1? No, I mean, for 1 to be a string, that needs to be 1, right? Because the one string isn't only in one place in memory. It's literally the exact same thing. What about this list? As a matter of fact, list 2 is array, empty array, is that? Or is this list a list? Well, if we run this, I still get false. And this is a little tricky and also advanced. Every time I create a list, it's added in memory somewhere. So this is in a location in memory. But whenever I create a new list, it's created in another location. So these are two completely different lists that live in different locations in memory. So it's going to check, hey, is this in the same memory space, same bookshelf as that one? Nope, that's not it. Wait, why does this work for things like numbers and strings? And that's because underneath the hood, these are types that are very simple, that are in memory but in one location, versus something like a list, even though this might be the same list with the same items. Because this is a data structure, every time we create it, it's created in a new location. So that even if we have a variable A that contains this list, and by the way, this will be the same for all our data structures like dictionaries, sets, tuples. If I do B equals this, and I check A, is that B? Nope, they're created in a different memory space. So this, where A points, is in a different place than where B points. But if I do A equals to B, I get true because this double equality checks only the values. Now, this is a bit of a hard topic, so you might have to watch this video a couple times, you might have to practice this a few times yourself, but just keep in mind the difference between is and double equals. Is tends to be a little stricter. You're checking for the exact thing that you're looking for, versus equality, which checks the value. Alright, that was a doozy. I'll see you in the next video. Bye bye.